All right, so now we are going to change up how we talk about the parabola. So here we want to come up with an equation for a parabola that has this directrix and that focus. And I think this is one of those things where if you draw the picture, it makes a lot more sense. So we see the directrix as a vertical line, so let's just go ahead and draw that. And this is x is equal to positive 7. Now we already know that if we have a directrix that's a vertical line, we're looking at a sideways parabola. Now the focus is 4, negative 5, so in relationship to this, it's going to be somewhere over here. So this is going to be 4, negative 5. All right. Now, where is the vertex? Well, the vertex is going to be exactly halfway between the focus and the directrix, right? And looking at what we have right here, we automatically know that our y is going to be negative 5. It's finding the x, right? So what's halfway between x is 4 and x is 7? We do the math, and you come up with 5.5. So you see 5.5, you can say 11 halves, it's all the same. And we'll have a parabola that opens to the left. All right, so let's start to put this together. Because it opens up to the left, it's going to be one of these guys that's like y something squared equals, and because it's opening to the left, there's going to be a negative. Got to find that number, and then x with something, right? So let's use the coordinates for my vertex. So x minus 11 halves and y plus 5. All right? Hopefully that makes sense. Nothing too crazy there. Now, when we looked at this stuff before, we know that this is A and that's A, right? So the distance between these guys is 2A. So we can see here that 2A is going to be a distance of 3 when you go from x equals 4 to x equals 7. But that means that 4A is going to be double that, and that's going to be 6. So this should be our equation. So we found the vertex, and then we just had to figure out what A was. And then we had to do 4 times that. Now you could look at this and say, oh, but I thought A was 1.5. Okay, so if I do 4A, that's 4 times 1.5, which is still equal to 6. All right, let's look at the next one. So it tells me that my vertex is -3, -1. That's super helpful, right? I feel like we're done. And then they just tell me that we've got a point on the parabola that is -5, -4. Okay. So let's see if we can figure out what is going on here. Now we could actually have 2 different answers for this. So let's find both of those answers. So let's look at the 2 forms that we have. We have the form that says x minus h squared is equal to 4a times y minus k. But then we have the form that says y minus k squared is equal to 4a times x minus h. All right, so here's the thing. Since we know the vertex, we already know h and k for both of these. What we don't know is the a. The a is not given to us, and we need that. Well, we can use the point that they give us, keeping in mind that the point is the ordered pair x and y. So you can plug in the x and the y, and all you'd have left to find is the a value. So let's do that here when you have a parabola that's that's opening up or down with x squared, and let's see what we come up with. All right, so this x value is -5 minus h, so that's going to become +3 squared equals 4a times My y value is negative 4. My k is negative 1, so minus negative 1 is plus 1. All right, let's just work this out. So this is negative 2 squared is positive 4 equals 4 times a times negative 3. So 4 is equal to negative 12a, and dividing by negative 12, a is equal to negative 4 over 12, which is, I don't know why I'm doing this, right? Because, yeah, we need to know what a is. So I could say, yeah, this is negative 1/3. But really, I just need to figure out what 4a is. So if I were to take this equation right here, and let's pretend I didn't do all of this. From here, if I just divide by negative 3, we would have that negative 4/3 is equal to 4a. Yeah, I said I wanted a, but really, if I get 4a, then I'm done, right? So let's take this information. Let's take, that's my 4a, and that's my vertex, and let's write our equation. So that becomes x plus 3 squared is equal to negative 4/3 y, and that becomes plus 1. So that would be an answer for a parabola that opens up or down. Well, I guess in this case it's opening down. And if you were to kind of plot these points to get a sense of where things are, so negative 3, negative 1, and then negative 5, negative 4. So you have two options here. The first one, like I said, was the x. And so if this is your vertex and you got to go through this point and you're an x squared parabola, you're going to be opening upside down. If you're a y squared parabola and this is your vertex and you have to connect to this point, then that would force you to become a left opening parabola. Now let's see if that's true. Okay. So let's do what we did here on the left, and let's plug in our x, y, h, and k. You got to be careful though, because I know it's very tempting that I see the y first and I want to plug in x. No, the y value is negative 4 minus k, so plus 1 squared equals 4a times x is negative 5, h is negative 3, so that's going to be a plus 3. Negative 4 plus 1 is negative 3. Squared is 9. So 9 equals 4a times negative 2, which means 4a equals negative 9 halves. So that's what 4a is. There's your vertex. Put this all together in an equation. So this becomes y plus 1 squared equals, and again, I didn't need to actually find what just a is. I'm looking for 4a. So this is negative 9 halves times x minus negative 3 becomes plus 3. And so you can see that both of these would have the vertex of negative 3, negative 1, and you can verify that the point P, negative 5, negative 4 would satisfy each of these different equations. That was fun, wasn't it? All right, let's do one more. Suppose I say the vertex is the ordered pair 5, 6, and the directrix is y equals negative 1. All right, so right away, since we have a directrix that is horizontal, I'm expecting my parabola to be either opening up from that or to be opening down. You know, let's draw a picture just to get an idea, get a sense of what's going on here. So here is y equals negative 1. My vertex is 5, 6, so that's going to be above it. So right here, 5, 6. How do I know it's above it? Because the y value is 6, and 6 is bigger than negative 1. So my parabola should be opening up like that. Okay. All right, so let's see. If I look at my equation, I have x minus 5 squared equals, this is where the 4a is going to go, right? We got to figure out what that is, times y minus 6. All right, so let's find 4a. Well, remember what we talked about, how the distance between your vertex and your directrix is just a. So between 6 and -1, this is a distance of 7. So 7 times 4 is going to make this 28. And because we are opening up, it's going to stay as a positive. So, pretty cool, right? I think so. Yeah, so you draw the picture, get a sense of what's going on, figure out your a value. Now, for this problem, I could go even further. I could say, hey, what's the focus? Well, once we identify that a is 7, the focus is going to be 7 units up from here. So the focus would be 5, add 7 to the 6, and that's going to be 13. I could go on and say, well, what about the latus rectum? What do you know about those points? Well, if we're at 5, 13, a is 7, so the distance to each of these endpoints of the latus rectum would be double that, so it'd be 14 to the right, 14 to the left. So to the right would make this 19, 13, and to the left, so 5 minus 14 will make that -9, 13. Right, so extra things that we could ask about this. So I could say, here's the vertex, here's the directrix. What are the endpoints of the latus rectum? That'd be pretty fun, right? Now, let's keep going with this. What's the domain? Well, the domain is going to be all real numbers. And what's the range? Range is bottom to top, so that's from 6 to infinity. What's the axis of symmetry? Well, the axis is going to be this guy right here, and that's x is equal to 5. And we could backtrack and look at the other examples we did in this video. For this one, we could talk about, what's the domain? Well, if it's this guy right here, the domain is all real numbers. And then the range is going to be -infinity up to -1. Over here, the picture is very helpful. The domain is -infinity to this x value of -3, and the range will be all real numbers. And you can talk about what is the directrix, what's the focus. And for this one right here, so we already have the directrix. You've got the focus, we've got the picture. We could answer the question, well, what is my axis of symmetry? Well, that's going to be y equals -5. We know what our vertex is because we already figured that out. We wrote that equation, and that was the ordered pair, 11 halves, -5. We could find the points. We found the points for the latus rectum. So A was 3 halves, so 2A, see there's 3. So that means for the latus rectum it would be going up 3 and going down 3. So the endpoints would be 4, add 3 to that y, makes that -2, subtract 3, so then you'd have 4, -8, right? And we could ask about what's the domain. Well, it's -infinity up to the x value for the vertex, so up to 11 halves, and the range would be all real numbers. So get the picture, find the a, and you've got everything else.